Unit 2's material covers some very important and central concepts in logic. First of all, we will learn the distinction between inductive and deductive arguments. Next, we will look at the concepts of validity, soundness, strength, and cogency. Also, we will learn how to identify the structure of extended arguments, that is, arguments that have a larger number of premises. And we'll do a couple of more things just to keep matters fun. So in the first part of Unit 2, you need to determine whether each of the following arguments is best construed as inductive or as deductive argument. Circle the correct answer. Number 1, since I have already won the state lottery last year, I certainly won't be winning it this week. Is this inductive or deductive? Notice that if you assume the truth of the premise here, it still will not render certain the fact that you will lose the lottery of this week. It's still, to some degree, actually a rather small degree, probable, but there is no insurance that the premise gives to the truth of the conclusion. Therefore, it's probably likely that what is intended here is that the premise gives just some evidence for the conclusion, making the conclusion a bit more probable than you might otherwise think. So the argument here is inductive, and in fact, this is not a very good argument at all if you consider it. How you fared in the lottery previously really has very little effect at all on how you might do this week. Number 2, Sally is an athlete. It follows from the definition of athlete that she will be able to jog faster than me. The key to this question is the reference here to the definition of athlete. The idea is that it is supposed to follow from the concept or the definition of the term athlete that a person jogs faster than a non-athlete. Since that's what's intended, in other words, the truth of the premises is ensuring the truth of the conclusion, making it impossible for it to be false, this is intended to be a deductive argument. You may well wish to ask yourself if the definition of athlete in fact does entail that somebody could jog faster than me. That's probably not the case. But the intention here pretty clearly is to render the conclusion certain on the basis of the premises. Number 3, George Bush is a wealthy man. Therefore, he is very likely to favor the interests of the wealthy in his presidential policies. Well, likely here, I think, tells you what's going on in this example. The fact that George Bush is a wealthy man doesn't make it certain that his policies will favor the wealthy. The truth of the premise does not ensure the truth of the conclusion, does not make the conclusion follow with necessity. It may, in fact, make the conclusion likely or probable to a high degree. Therefore, it's best to think of this argument as an inductive argument, and it may well have some strength to it. Number 4, all logic instructors are geniuses. All geniuses are out of touch with reality. It follows that logic instructors are out of touch with reality. Well, I think there's something wrong with this argument. I hope you do too. But let's first ask whether this is an inductive or a deductive argument. If you assume the premises to be true, that is, that every logic instructor is a genius and that all geniuses are out of touch with reality, there's no way that the conclusion can be true. In other words, its truth is rendered necessary on the assumption that the two premises are true. So this argument is deductive. In fact, it is a deductive valid argument. What's wrong with the argument, of course, is that at least one of the premises are true. Or sorry, at least one of the premises are false. Notice, logic instructors are not all geniuses. In the next part of the test, we will be looking at arguments, and we need to determine whether they are valid, invalid, sound or unsound, strong, weak, cogent or uncogent. Before we begin these, you should remember that the 4 concepts, validity, invalidity, soundness, and unsoundness, apply to deductive arguments, whereas strength, weakness, cogency, or uncogency apply to inductive arguments. So the 2 answers that you give on these should both belong either to the top 4, the group of top 4, or to the bottom 4. So number 5. Once in the CI bar I was struck in the head with a beer bottle, I assume that the place is still a rowdy joint. First ask yourself, is this inductive or deductive? Well, this is an inductive argument because the general conclusion that the place is a rowdy joint is meant to be supported by, in this case, only one instance. At best, then, the conclusion would be rendered probable, but certainly not certain, on the truth of the premises. So the argument is inductive. How strong is the argument? Well, not very. In fact, it's a weak argument because it's an attempt to get to a general conclusion based upon one, perhaps isolated, instance. And because it's weak, it also is the case that the argument is uncogent, since to be cogent, an argument has to first be strong. Therefore, a weak argument can only be uncogent. Number 6, all of the movies Dustin Hoffman has been in were great. Dustin Hoffman played the whale in Moby Dick. Therefore, Moby Dick was a great movie. Is this a deductive argument or an inductive argument? Well, if you are willing to assume that the two premises are true, then the conclusion must be true. It can't be false. Therefore, this is a deductive valid argument. But of course, something is wrong here. Everybody knows that Dustin Hoffman, as good an actor as he is, never played the whale in Moby Dick. Therefore, we have a false premise here, which makes the whole argument unsound. In the next part of the Unit 2 test, you need to give the answer true or false. 7. A deductive argument with false premises and a false conclusion must be invalid. Well, consider the concept of validity. The concept of validity says that the truth of the premises ensures that the conclusion is true, makes the truth of the conclusion follow with necessity. Can a deductive argument whose premises are actually false and whose conclusion is actually false be valid? Sure, because the concept of validity simply says that if the premises are assumed true, then the conclusion must be true. It doesn't commit you to the fact that the premises are in fact true. So take this example. All birds are blue. That's certainly false. All blue things are metal. Also false. Therefore, all birds are metal. Here we have a valid argument. It's got false premises. It's got a false conclusion. Right? But it's valid. Therefore, the answer to 7 is false. Number 8, all valid arguments are deductive and some valid arguments are unsound. Take the first part, all valid arguments are deductive. Is this true? Yes, because remember, deductive arguments are either valid or invalid. In other words, if these are all the deductive arguments here, then the valid arguments are a subset of those deductive arguments. What about the second part? Some valid arguments are unsound. This is also true because the soundness of an argument is a matter of the premises being actually true. A valid argument can, as we just saw, have false premises. So a subset of valid arguments are sound. Some valid arguments are not sound. Therefore, the answer to this is true. Define these following couple of terms. An invalid argument. Again, think of the concept of validity, the central concept. For an argument to be valid, it first has to be deductive. For it to be valid, there has to be a successful relation between the premises and the conclusion. It must be that if you assume the premises to be true, then the conclusion follows with necessity. An invalid argument is simply an argument which is not valid. Therefore, its definition is a deductive argument whose conclusion does not follow with necessity from the truth of the premises. Number 10, a strong argument. Remember, strength or weakness are concepts that apply only to inductive arguments. And if an argument is strong, the conclusion follows from the assumed truth of the premises with probability. That is, the premises render probable the conclusion. In the next part of the test, we need to learn how to use the counterexample method to determine that an argument is in fact invalid. Here's the argument. No heavy drinkers are safe drivers. No Mormons are heavy drinkers. Therefore, all Mormons are safe drivers. To do the counterexample strategy, you first have to determine the form of the argument you're working with. A, B, and C here are to be assigned to the particular terms in the argument. We first need to identify the conclusion. Therefore is a conclusion indicator, and therefore all Mormons are safe drivers is the conclusion. We get then the form all B are C for the conclusion. What about the first premise? No heavy drinkers are safe drivers. That will be no A are C. And the second premise, no Mormons are heavy drinkers. That will be no B are A. So that's the structure of the argument. Now what we need to do is to figure out three terms, A, B, and C, different from the ones in this argument, where when we put them into these slots, we get quite clearly the truth value true for the first premise, true for the second premise, but false for the conclusion. Remember, the idea behind this strategy is this. You show an argument is invalid if you can show that it's possible that the two premises are true, but the conclusion is still false. That would show, obviously, that the premises don't ensure the truth of the conclusion. So we need to come up with an A, B, and C that make the premises true, conclusion false. How do we do this? Some of these examples are a little harder than others, and so this little rule of thumb might help you. Try to visualize the relationship between the three concepts that we need. You need an A and a C so that the first premise, no A or C, is true. So let this circle here represent all the things that are A. Let this circle here represent all the things that are C. The fact that the circles don't overlap indicates that no A or C. Now we need to introduce a circle that represents B. Notice when we do that, we need to make both the second premise, no B or A, true, but we also need to make the conclusion, all B are C, false. Well, think about the conclusion for a moment, all B are C. That must be false. If it's false, then some B, at least, must be not C. Another way that the conclusion could be false is if no B were C. Well, that means that if we were to put B in this position, then not only would no B be A, but also no B would be C, and that latter fact would make the conclusion false. Therefore, if we can come up with an A, B, and C that are related like this, that is independent of each other, we will be able to come up with the counterexample. So, how about this? Let's let A be frogs. Let's let B be cows. And let's let C be, birds. Now notice the first premise says, no A, no frogs are birds. That's certainly true. The second premise says, no B, cows are A, frogs. That's certainly true. And yet, all B are C, all cows are birds, is false. So this assignment, frogs A, cows B, birds C, gives us a counterexample and shows that our original argument is in fact invalid. One last question on this Unit 2 test. This involves extended arguments. Extended arguments, as you can see from this example, contain a large number of premises. What you need to do in number 12 is to determine which tree or diagram actually indicates the logical structure of the argument as it's given. So let's read the argument. Oliver North should be hailed as a national hero. First, North always acted with conviction, since he viewed communism as an inherent evil. Moreover, his public lying was justified because of his belief that the Nicaraguan government was Marxist. Lastly, he was all along selflessly following the dictates of the president. We need first to determine what the conclusion of the argument is. Well, if you think about 2, 3, 4, and 5, you'll see that these really are producing reasons for you to believe the truth of 1, that North should be hailed as a national hero. So 1 is our conclusion. Now we need to ask about the relationships between 2, 3, 4, and 5. And let's now go to one possible graph and see whether in fact the graph gives us the structure of the argument. If you have the circled numbers stacked on top of each other in this way, this indicates that 3, premise 3, the idea that communism is evil, was to be a reason to believe 4, that North's lying was justified. And similarly, that the premise 4 was a reason to believe number 5, that North was simply following the president's requests. All of these then are above 1 because 1 is the conclusion, and 5, following the president's request, is the reason that you're to come to believe that North should be hailed as a hero. Is this the correct structure? Well, notice again in our example, the since here indicates that 3, he viewed communism as an inherent evil, is a reason for you to believe 2, that he always acted with conviction. Notice this graph, though, doesn't even have 2 on it, and therefore can't be correct. So let's try another graph. This one at least has 2 on it, so we know we're in the ballpark. What's important about this graph is the bracket here. Brackets, you remember, unlike single lines, indicate that the bracketed premises, 2, 4, and 5 in this case, together as a whole constitute a single reason to believe that North should be hailed as a hero. Is that right? Let's go back to our example. Notice that 2 says, first, he acted with conviction. 4 says his lying was justified. 5 says, lastly, he was selflessly following the dictates of the president. These are clearly 3 different reasons for believing that North should be a hero, and therefore this bracket is incorrect. 2, 4, and 5 don't fuse together to make one reason to believe 1. Look at this graph, and now we've got the right one, because as you see, as we saw before, 3 is a reason to believe 2. 2, 4, and 5 individually are reasons to believe 1. And that's represented by each of 2, 4, and 5 having its own line down to the conclusion that North should be hailed as a hero. So this third one is the right answer. And that's it for Unit 2. I hope that wasn't too hard. We'll see you again with Unit 3.